Hello students, let us once more try to understand the resonance because some students are facing still problem. So resonance is what student representation of molecule in more than one structure. Representation of molecule in more than one structure and none of them explain all the properties of the molecule singly is called the resonance structure. Okay. Now try to understand with the help of example. Okay. Take a benzene structure. Okay, so one structure is possible like that. Here you can put the double bond. Another structure is also possible. You can you can put the double bond here and here. Okay, see, as per the rule, carbon carbon single bond is how much? 1.54 angstrom. And if you talk about the carbon carbon double bond, it should be the 1.34 angstrom. Okay, so it should be this bond should be how much length? This bond double bond 1.34 and this single bond should be 1.54. But this is not. Suppose 1.34 it should be and 1.54 it should be, but this is not happening. What is actual bond length, student? What is actual bond length? If you talk about the actual bond length, experimental bond length is what that is. This is like that 1.39 angstrom. 1.39 angstrom. Okay, so what is the resonance? When see, read out again the statement. Okay, representation of molecule in more than one structure and none of them explain all the properties of the molecule is singly is called resonance. So we are representing with the two structure, but none of them is able to explain the property because actual bond length is 1.39 angstrom. But here how much? 1.34 angstrom should be, 1.5 angstrom should be. So these are the resonance structure. These are the resonance structure. Okay. But what is the correct structure? This is the resonance hybrid structure. Resonance hybrid structure. Okay, resonance hybrid structure. So how can you define resonance structure, student? The representation of molecule in two or more than two structures. So this is a resonance structure, a resonance hybrid structure. This structure is represented by case 1 and structure 2. But these neither 1 nor 2 is able to explain this bond length because it should be 1.54 and 1.34, but it is not happening like that. So what is correct structure? Resonance hybrid structure. Hybrid structure is structure of first and second. So 1.39 angstrom. So this is correct one. Now let us try to understand with the help of. Whenever a single Lewis structure cannot describe the molecule accurately, a number of structures with similar energy, position of atomic nuclei, bonding and non-bonding pair of electrons are taken as the canonical structures of the real structure which describe the molecule accurately. Okay, so they are saying this is the canonical form of ozone. So this is canonical structure 1 and 2. So here what is there? 1 is double bond. So this double bond, what is happening? This double bond, one bond is shifting here. So now next one is here. This is continuously reversible process. Sometimes this bond will go here and sometime it will go here. So this structure is known as canonical structure. You can read out again, student. Whenever the single Lewis structure cannot describe the molecule accurately, a number of structures with similar energy, position of atomic nuclei, bonding and non-bonding of the electrons are taken as the canonical structure of the real structure which describe the molecule accurately. Now these two structure undergo the hybrid. Okay, so in between of these two structure means this bond is continuously rotating with this and this. So what will happen, student? Here it will be the dotted line is there. Dotted line. It means what the dotted line is saying? This dotted double bond is also with this line, with this bond and with this bond. So this is what is known as resonance hybrid structure of O3 molecule. This will explain the property of all the property of the ozone molecule. Thus O3, the two structure 1 and shown below constitute the canonical structure or resonance structure, and third structure represent the structure of O3 more accurately, and it is called the resonance hybrid structure. Characteristics of resonance. Okay, Resonance stabilizes the molecule. What it will do, resonance stabilize the molecule. More the number of resonating structures, more will be the stability of molecule. Because of the resonance, all the bond length become same. All the bond length in benzene are identical. The canonical form have no real existence. Okay, the canonical form have no real existence. The resonating structure are inseparable. The resonating structure are inseparable. The molecule as such has a single structure which is resonance hybrid of all the canonical form, and which cannot as such be depicted by the single Lewis structure. Okay, what is meaning of this? Bond order is number of bonds between two atoms in all the resonating structure. Total number of resonating structure, you see, this is the CO3 minus, they have second CO3 2 minus. So how they are making the bond? First time double bond is here, second time this double bond is moving here, and this lone pair electron is going. So negative charge came, double bond here, and again this double bond is shifting here, so this came here, and negative charge is accordingly shifting. So resonance structure of this three molecule. And what would be the hybrid structure, student? If you want to see the hybrid structure, C is there, O is there, O is there, and O is there. So if with this all the places there is double bond will go, student. Okay, all the places double bond, and here is negative, they will acquire the negative also. Next one, you see resonance hybrid structure. This is benzene, already we will explain. This is first structure, this is second structure, and this is the resonance hybrid structure. Any other slides? What is the concept of resonance? In chemistry, resonance is a way of describing bonding in certain molecule or ions by a combination of the several contributing structure form, also known as resonance structure or canonical structure, into resonance hybrid or hybrid structure in the valence bond theory. Next one, what is there? What is resonance energy? Explain. The difference between the potential energy of the actual structure and that of the contributing structures with the lowest potential energy is called resonance energy. Delocalization energy. Benzene is an important organic chemical compound with the chemical formula C6H6. Nothing is there in to explain. Here is a one they have taken, that is NO2 minus. First time this double bond is here, second time the double bond is here, and lastly this is the position. Here is the, they mention that is double bond is delocalizing on the all the both the atom. So this is the resonance hybrid structure. So this is all about the resonance structure. Student, you try to read out the book, you will be able to understand. Still you are not able to understand, just text me message. Thank you, students.